Hi guys, welcome to my channel. In this video, I'm going to talk about elastic spring and strings. Okay, first I'm going to talk about the differences between strings and springs. The first difference is string has a letter T in it and springs has a letter P in it. Okay, why would I talk about something like this? Because a lot of people, when they're trying to be flash when solving question, they tend to make mistakes, and it's really important that you don't make this kind of mistakes. Because if the question is talking about strings and you solve it like a springs, I can assure you that your answer will be 90% wrong. Okay, here's why. The difference between string and spring is spring can be compressed or extend, but string cannot be compressed. So imagine you have a wire or something, and if you try to pull it, it can be stretched. But imagine if you try to push the wire, it gets slacked, which means like this. Yeah, this is called slacked. So it will get slacked and there will be no tension in it. Okay, the second thing is about Hooke's law. The definition of Hooke's law is the restoring force, which means the tension, is directly proportional to the extension or the change in length of spring or strings. Okay, so if you make it into an equation, it will become F equals to K delta X. Okay, what is this K? So this K is actually called spring constant. But in math, we don't use K. We use something instead, which is lambda L times X. So lambda is the modulus of elasticity. It means how elastic a material is. So the difference between the spring constant and the modulus of elasticity is spring constant depends on the dimension of the springs. For example, the thickness of the springs, the length of the springs. For modulus of elasticity, we talk about materials. So whether it's a steels or whether it's a aluminium or tin. And one thing I want to add about modulus of elasticity is you can also say that it's the measurement of how stretchiness a material is. Okay, the next thing that I want to talk about is elastic potential energy. Okay, what is elastic potential energy? For example, if you have a spring or string, and when you extend it, there will be elastic potential energy inside the spring. And this elastic potential energy will tend to return the spring or string back to its original form. So how to calculate elastic potential energy? In terms of graph, and force in the y-axis and extension in the x-axis. For example, we have a linear graph and this is x. Let's change this to E and this is F. Okay, so the work done, which means the elastic potential energy, is actually the area under the F against extension graph. Okay, so to calculate this area, we know this is a triangle, a half angle triangle. So the work done will be equals to half F times X. Okay, so this is one of the formula for elastic potential energy. So F is also equals to lambda x over L times x. So the work done will be half lambda x squared over L. So this is the elastic potential energy, the formula for elastic potential energy. So the other way to find the elastic potential energy from the graph is by using integration. If we use integration, it will be sum of the small change in extension. So the work done will be from 0 to x, which is the limit, with f times the small change in extension. So in here, f is also equals to lambda e over L dE. So by integrating that, is equal to 2L x0. So we sub x and 0 into the equation, we get lambda x squared over 2L minus 0, which is lambda x squared over 2L, which is the elastic potential energy. So in physics, the equation you use for elastic potential energy might be EPE equals to half kx squared, where k is actually similar to lambda over L. So that's all for this video. If you learned something from this video, please leave a like and subscribe to my channel. And I will see you in the next video.